just looking at combinations with certain conditions. So this is where we choose a group of people. So we're choosing a group, and the order does not matter. So the order doesn't matter. So we say that is unordered. So it's like choosing a group of people for a committee, but not worrying about putting them in positions, like first, second or third, or captain, vice captain, secretary. So unordered. Okay, let's go. So looking at the first example, we want to pick 6 people for a committee, and we want to choose those 6 from 6 girls and 6 boys. So that means we're actually choosing it from 12 people. So it's coming from 12 people, and we want to choose 6 of them. So that would be 6C, 12C6. That's when you have no restrictions. You're just going to pick them. You don't care if they're boys or girls or whatever. Okay, so if we look at the second one, there is an equal number of boys and girls. So there's an equal number of boys and girls. Okay, so that means that if we're going to have 6 people in the committee, that means we need 3 boys and 3 girls. So the 3 boys would have to come from 6 boys, and the 3 girls would have to come from the 6 girls. So you can use perms and coms to do that. So we're going to have 3 from the 6. So 6C3, that's for the girls, and 6C3, that's for the boys. And you just got to work that out, and you get the total number of possibilities. Okay, what about if there's at least one girl on the committee? Now you could do this in 2 different ways. At least one girl, if we're choosing 6, would be 1 girl and 5 boys. We would have 2 girls and 4 boys, because it's got to add up to 6. 3 girls, and that would be 3 boys to add up to 6. Or you could have 4 girls and 2 boys. That would add up to 6. 5 girls and 1 boy, add up to 6. Or 6 girls and 0 boys. So you could add all these up separately, okay? Or you could think about what's the only one, there's only one that is missing from that list, and that would be all the boys. So what about, instead of doing that, that's 5 boys, maybe what we could do is do the total number, like with no restrictions, which would be 12C6, and you minus that they are all boys. Now there are 6 boys, and we're going to choose 6 from 6. So from the 6 boys, we're going to choose the 6. So it's 12C6. 6C6 is just 1, and you just work it out. Because if you didn't do that, you'd be doing 1 girl, 1 boy, would be 1 from the 6 times 5 from the 6. And then you go 2 from the 6 times 4 from the 6 boys, etc. 3 from the 6 times 3 from the 6. Or you might be doing 4 from the 6 times 2 from the 6. Or 5 from the 6 times 1 from the other 6. Or 6 from the 6 girls. And you can see there's a lot of calculations in order to do that. Okay, so you're better off doing what's called the complementary event and doing the total number with no restrictions, and just taking away when it is all boys. Get exactly the same thing. Okay, now we're going to now look at this one here. So if a particular boy and a particular girl need to be on the committee, so that means that they have to be on the committee. So if they have to be on the committee, what you need to do here is you need to choose them first of all. So you choose 2 from 2, because they're definitely on there. Then you have 4 left to pick. Now, if we have 12 people altogether and we choose 2 of them, that means there'll only be 10 left. So the remaining 4, you would choose from 10, and the order doesn't matter because we're not choosing them for positions, we're just choosing the committee. So that'll be 10C4. Okay, part 4, same question. Okay, we're choosing a committee of 6, we're doing it from 12. 2 people cannot be together. So if they cannot, that's the situation where you do the total minus they can. So we did they can in part 4. So now if we do the total would be 12C6, and then I have to take away what's up the top. 2C2, 10C4, and I need to take that away, that's what's there, and whatever I have left, that will be the number ways of organising that. And just finally, 4 boys and 2 girls. So that would be 4 from the 6 boys and then 2 girls from the 6. And that would do that combination. So just a couple more to consider. A particular male must be excluded. That means then from the males, you only have 5 males and 6 girls to choose from. So that would mean that when you're choosing the 3, so when you're choosing this, that means, so you got 11 people, and you're choosing 6 from 11 instead of 6 from 12. Zach refuses to be on the committee with John, so what you need to put is put both on the committee. So if you put both on the committee, and then what you do is you do the total minus both are on the committee. Okay, so the total would just be 12C6 minus, they're both on the committee, so remember there are 12 people and we're choosing 6, and of those there's 6 boys and 6 girls to choose from. So 12C6 and both are on the committee, that would mean 2C2 because they're definitely on there, with 4 left to pick from, 10. And that would give you your answer. So a basketball team of 5 is to be chosen from 8 players. How many ways can this be done if there are no restrictions or Israel must be picked? So no restrictions, that would be 5C8. And if Israel must be picked, you pick Israel, 1 from 1. And then you got 4 left to pick. So 8 minus 1 is 7. You only have 7 players to choose from. So it's times 7C4.